তোমার কম্বলটা দিয়ে দিই।
না না না
Okay, so let's begin today's lecture. So today we'll go to the next module, which is on regular expressions and finite automata. So we'll slowly see what is their significance and what are our motivations. So here is a reference. It's a different textbook. Okay, so let's begin. So regular expressions are some kind of a syntax for describing string patterns. So some of you might have encountered it in text editors or in some programming languages. You may want to search a text which falls under a certain pattern. So for example, A, B star C is a string which consists of an A, some number of B's, and C. So you want to search for a pattern of this form. So then you have to specify the text editor in some way. So regular expressions are a formal syntax for doing this job. Okay. Now, what are we going to do? Is we will try to understand a little bit about regular expressions, writing regular expressions. So we'll try to develop a formal understanding of these patterns. And the second thing that we want to do is, so if you are given a text and you are given a regular expression and you want to find if there exists a string that matches that pattern. Okay, so we will try to see an algorithm for this. Okay, so but today we will just do regular expressions. Okay, so I guess some of you would have already seen this, but I also believe that there are several of you who have not seen regular expressions before. So maybe I can try to take a poll. Wait. So can you say, so just say, I mean, just say yes or +1 if you have not seen regular expressions. So I want to know people who have not seen regular expressions before. Okay. So, yeah, indeed, there are several of you. Okay. So what about automata? How many of you have not seen automata? Again, just say +1 or yes if you have not seen automata. Okay, but there are a sizable of them who have also seen it probably. But so I request them to not steal the thunder. Okay. So if you know the answer, please stay quiet. This is for people who have not seen this. Okay. Yeah. So before we get into it, we want to define the objects on which we are going to work. Okay. So they're not going to be numbers or, propositional formulas. No, we are going to work with a different kind of objects. So these objects will be called languages. So what are they? So I'll first start with a basic building block, which is called an alphabet. It's just a finite set. Uh, Sigma is a finite set of symbols. For example, sigma 1 equal to a comma b is one alphabet. Say sigma 2 being 0 comma 1. Else. So the English alphabet, say let's call it sigma e, a b c d x y z is an alphabet. It's just a finite set of symbols. Okay. Now this is the first thing. The second thing is words. And as you might expect, so given an alphabet, a word is a finite sequence of symbols. Okay, so suppose I assume, so for the purpose of this class, just assume that I have been given a sigma which is equal to a comma b. We are not going to work with anything else for the moment. Okay. So then a word is just examples of words a b a b b. I mean b a b a b b b a and so on. Okay. A word is something else. So once we have this, then what is a language? A language will be a set of words. Okay. Okay, a set of words from this alphabet we will call a language. Okay, so let's see some examples. So a language specifies some kind of a property of words. So I can say L1 to be the set of all words that start with an A. So remember that we have fixed our alphabet to be A comma B. So I'm not going to repeat that. Okay, so this L1 is a set of all words that start with an A. So what are they? A, no, A, B, A, blah, 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 and so on. So how many words are there in L1?
Infinite.
Yeah, there are infinitely many words. So there are words in L1. Okay, so let me look at some other language. L2, words that contain AB as a substrate. Okay, so again, there are infinitely many words. So some of the examples are just AB, AAB, say ABA, and so on. Okay, so these are all examples of languages. L1, L2 are examples of languages. So languages will be our building blocks, just like propositions. Here our smallest elements will be just languages. So starting from languages, we are going to do various things. Okay. So now, so I need to go through a certain set of definitions before we can start doing examples. Okay. So as I said, in the case of propositions, we had given propositions, we could do and, we could do or, we could do not, we could do implies, right? Now, in this case, my starting set, I mean, my starting elements are languages. What are the things that you can do on top of that? So there are several, I mean, there are four operations that I want to talk about. Union. Okay. Given two languages, L1 and L2, you can do L1 union L2, which is just the set theoretic union. L1 is a set, L2 is a set. Now L1 union L2 is just the set of all words which are present either in L1 or in L2. So set of all words such that, okay, I'll use W. Set of all words such that W is in L1 or W is in L2. It's just a set theoretic union. Similarly, you can talk about intersection. Okay, so for example, if L1 was the set of all words that start with an A, L2 is the set of all words that end with an A, L1 intersection L2 will be the set of all words that start as well as end with an A. Okay, now the next thing is complement. So I give you a language L, and then I'm taking a complement. This is once again the set theoretic complement. So you have the set of all words. Over A comma B. Okay, and then L will be some subset, right? The rest of the words will be L complement. Okay, no surprise. Okay, so there's one final operation that I want to talk about, which is star. Which is, so given a language, I want to apply an operation called star on top of it. So what is this? Okay, so I'll first give you the definition. This is the set of all words of the form W1, W2, W. Okay, wait. Before that, I'll so before I go to star, let me give some short other notation. So what is L dot L? Okay, I have to give. I forgot about this. So, something called a concatenation. Okay, if I have a language L1, I have another language L2. L1 dot L2 is the set of all words W1, W2, such that W1 is in L1, W2 is in L2. So for example, suppose L1 is the set A, B, A, okay? And L2 is the set, so this is a finite language, okay? This is the set B, B, okay? So then L1 dot L2 is like a cross product, something like that. So I take the first word and concatenate it with the words of L2. So they will be ABB, ABBA. Okay. Then I take the second word and concatenate with these two to get AA, sorry, AAB, AAB. Okay. Now suppose I have say L to B. Let me do it like this. L1. So here's another example. Words that start with A. L2, words that end with P. What is L1 dot L2?
L1 intersection.
Sir, should I write it in the chat?
Yeah, yes, please. Yes, please. Yeah. Yeah. So, yeah. So these are the words that start with A and end with B. So in this case, it turns out to be L1 intersection L2. Okay. Yeah. So the point is to understand what is L1 dot L2. So I think you understand. So you take a word in L1, concatenate with every word in L2. Do this. So here is another question. Is it true? Is L1 dot L2 equal to L2 dot L1? Well, the answer is there on the slide. Always, in general, in general. Yeah. So it's no, because you can clearly see here, if I take L1 dot L2, L2 dot L1 will be different. Okay. So maybe now I can ask you a question. So try to give two languages L1 and L2 such that I'll write it. So here's a question. Give two languages L1, L2 such that L1 dot L2 equal to L2 dot L1. So I'll give a couple of minutes. Just type it on the chat. The previous example does not work. Many of you say previous example. It doesn't work. I mean, if L1 is words that start with A, L2 that words that end with B, L1 dot L2 is words that start with A and end with B. But L2 dot L1 is not that. Yeah, so of course, if L1 is equal to L2, it works, yes. So people who said the previous example, do you understand now? Well, so there are comments that say that both the languages must be same, but that is not true. So if they are same, of course, L1 dot L2 is equal to L2 dot L1. But yeah, so no. Okay, there is one more wrong answer, which is L1 starts with A, L2 ends with A. See, there are several correct answers, so I'm not going to comment on them, but here are some wrong answers. L1 says starts with A, L2 is, they say, end with A. So what is L1 dot L2? Start with A and end with A. But L2 dot L1 is not that. So for example, BA, AB belongs to L2 dot L1. So because BA is present in L2, AB is present in L1. Because this ends with A, this starts with A. So people who said this start with a, end with a, do you understand?
Yes, sir.
Yeah, okay, okay. So, but there are several other answers. Yeah, you can. Yeah. So something like L1 is words of length 2, L2 is word of length 3. Length is a good argument. Okay. So I'll give you one right answer. One correct answer. Apart from say L1 equal to L2, say L1 is words of length 2, L2 is words of length 3. Okay. So finally L1.L2 and L2.L1 are words of length 5. Okay. Fine. Good. So you understand what is L1.L2. Okay, so this is, I want to talk about star now. So coming back to star. Sorry. So now I want to define L star. So first, I have L. Now L dot L is just L concatenated with L. I write it as a short form L2, L power 2. Okay. So instead of L1 dot L2, I'm just doing L dot L. Now what is L3? It's just L dot L square or L square dot L. Both are the same. Okay. Similarly, I can define L power n to be W1, W2, Wn such that each Wi belongs to n. Okay. So in L power n, you take n words. We pick n words from L and concatenate them. Then, so we need to worry about what happens when n is equal to 0. Okay, this is one thing which we have to worry about. Okay, so this is where, so what happens when you pick 0 words? Okay, so for this, we introduce what is called an empty string. Okay, so this comes from, if I give a word W, length of W is the number of symbols present. For example, A, B, B, A. So let me denote the length by this mod. Length of ABBA is 4. Length of AB is 2, and so on. So now epsilon is defined to be a word of length 0. Okay, so we just introduce this notion. So there is something called epsilon. It is a string, but it has length 0. Okay, a string of length 0 called, it's called the empty string. I mean, maybe you can, maybe should have been called a 0 string or something like that, but yeah, it's called an empty string. Okay, so now we copy this once again. L star so we understood L, L square, L power n, and so on. So we also need to define this notion of L0, which is just epsilon. Okay, just a singleton epsilon. So now what is L star? L star is L0 union L1 is just L, union L2, union L3, so on. So it's the union over all k bigger than 0, L power k. Okay, so we will see some examples now to see what is star. Okay, so let me see. Sorry.
Sir, L star is the power set.
Wait, no. Power set of what?
Power set of the language.
No. Wait. Okay, wait. I'll tell you why it is not. Suppose L is just A. Okay, what is L star? So you can just type on the chat. So just apply this definition.
So epsilon, A, and so on.
Correct. It has to start with epsilon, A, and so on. Infinitely many. So surely this is not the power set of L. You understand this?
Yes, sir.
Okay, good. Now suppose L is A comma B. Okay. What is L star? Just think about it for say 3 minutes. I want to give some time to everyone. Like I'll give you the answer at 4. Yeah, okay. So once again, L0 is epsilon. L is just A comma B. L2 is AA, AB, BA, BB. Set of words over A comma B of length 2. Okay. Now if you go on, L power n will be words of length n over A comma B. So essentially L star is epsilon union set of all words over A comma B. Okay. Fine. Okay. So at this moment, you should have understood the notion of alphabet, which for this lecture, we will just take it to be A comma B. The notion of languages and the operations union, intersection, complementation, concatenation, and star. L1 union L2, L1 intersection L2, L1 complement, L1 dot L2, and L star. Okay. So I hope up to this is reasonably clear to most of you. So now we will try to do an informal introduction to regular expressions through examples. Okay. So here is a task for you. Okay. So I'm giving, I have not taught you what this notation is properly, but still, just by looking at this notation, can you guess what is the language for each of them? This represents one language, this represents one language, and so on. So take some five, 6 minutes and try to write the language corresponding to each of these expressions. Okay. What do you think is the language? Yeah.
So these are the alphabets.
No. So the alphabet is A comma B. Okay. So if I write A star B, what do you think it is?
Oh, okay.
Okay. Yeah. Okay, so let me give you the answers. It was just to get you thinking about what this is. So now I'll give you the answers. Just copy this. So A star B. So how do you look at A star B? This is A star dot B. Okay, now what is A star? So you know, if I write L star, it is whatever that L0 plus L1. So this is just epsilon A, 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 and so on. Okay, so then finally A star B should be epsilon A, some A power n, so on, dot B. Okay, so this is just B, AB, A square B, A power n B, and so on. Okay, so this is A star B. So stop me whenever you want. Okay, so the second thing is AB plus BA. Sorry. So this is going to talk about a language. So this is just a finite language consisting of two words A, B, and BA. Because this plus stands for union, this is just concatenation of A and B. So that is AB. This is concatenation of B and A, that is BA. So this is just the set of two words AB, comma BA. What are the other things? Just B star A plus A star B plus A star. B star A plus A star B plus A star. So now once again, you have to patiently do what is this, what is this, what is this. So we have kind of seen all of them. Okay. See, B star A should just be A, B, A, B square A, blah, 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 B power I A. Okay. Union, A star B is the other way around. B, A, B, blah, 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 A power I B. Union, A star is just epsilon A square cube. Okay, so that is this. So this short notation stands for this infinite set of words. Okay, that's the thing to note. Now, what is 1.4? A plus B. Okay, so this is what? It's just words of length 2. A, B, B, B. Okay, this one is just, so if I take, so if you see that A plus B denotes the set A comma B. Okay, so this is A comma B star. If I take L to be this is the set of epsilon union set of all words over A comma B. So slowly we will, when we say set of all words, we also mean epsilon. Okay, so we will not explicitly write this. So epsilon is included in this. Epsilon here. Okay. This is this epsilon belongs to. So this epsilon is the empty string. This epsilon is for saying that is included in. Okay, just yeah. Anyway. Okay. So what about these two? So when I write sigma, it just means the set of all words, set of all letters in the alphabet. And sigma star is the set of all words. Okay, like A comma B, if sigma was A comma B star. Now, this says that you take every word, then you put an A, and then you take every word. Okay, so maybe I'll treat this specifically. Sigma star A sigma star. So this is going to be the set of all words that contain an A. Okay, because if I take, see, you have to show two things. If I take a word that comes out of this, it will be of the form W1A, W2. Okay, it will contain an A. Okay, words in sigma star A sigma star will be of the form W1A, W2. Okay, so they will contain an A. If I take a word that contains an A, if W is a word that contains an A, we can break it as, see, it contains an A somewhere. We can break it as W1 A W2, and so this belongs to sigma star A sigma star. Okay, so finally sigma star A sigma star is just a set of all words that contains an A, that contain an A. Okay, so what is the final thing? A plus AA plus B star. This is simple now. A plus AA plus B star. This will be A, AA, and then this set of all words of this one. Okay, so this is the, I will give a formal definition later, but this is the intuition. If you are given a regular expression, you should try to be able to infer the set of words associated with that expression. Okay, so now let's try to do the reverse. So take some time, try to write the regular expression for these languages. Okay, based on whatever you have understood about regular expressions. Okay, so let's discuss. So we also have more examples. So we should start discussing. So I hope you can see it. Okay. Okay. So now so what is 2.1? Set of words that contain AB as a substring. Okay. So I'm assuming my sigma is A comma B. So this will be A plus B star, which is some word AB, A plus B star. Okay. I don't know if you're able to see it. Okay. What about the second one? See, it has to contain both A and a B. Okay, so here is one option. See, but the A and B can come in any order. It can be A followed by B or B followed by A. Okay, so one option is just do A plus B star, A, A plus B star, B, A plus B star. Okay, plus A plus B star, B, A plus B star, A plus B star. Okay, so this is one option, but it can even be written in a much more succinct way. So anyone, any different answers?
So we can use that summation sign.
Okay, fine. You can write
Excuse
it
me,
as
sir.
once again, sigma star A, sigma star, sorry, sigma star B, sigma star plus sigma star B, sigma star A, sigma star. But I'm saying you can be even smaller.
Sigma star AB plus sigma star BA.
What is the answer? Sigma star.
Maybe, I'm not sure. AB
Ah,
plus sigma star BA.
so what about BAA? Where does it fall? See, BAA contains both B as well as A.
Yeah.
So how do you refine this answer? You're there.
Plus sigma star AA plus sigma star BB, I think.
No, if you do plus sigma star AA,
Sigma
then you
star
are adding extra things.
sigma star A star B star.
So can we have sigma star A, sigma star B, sigma star A, sigma star?
Which is this, no? Sorry, come again. What did you say? Sigma star?
No, yeah, after that we put A and then sigma star again.
Then, okay, if you do that, so you are forced
No.
to have an A,
Yeah,
a B.
yeah, I see the flow. I see the flow. Yeah.
Sir, is
Sir,
there a way
sigma star AB sigma star BA sigma star.
So come again. So tell me sigma star. Okay, what's the option?
Sigma star AB sigma star BA sigma star
Plus, right?
plus, yeah.
Yeah, this is correct. Okay, so you can even write it. So this one is not correct. You see why? This one is correct. See, if the word contains both A and a B, at some point of time, there will either be an AB or a BA. Okay, because if there is no AB, and if the word starts with A, it's just going to contain A's. Okay, and if it starts with a B, it's only going to contain B's. So if it contains both A as well as a B, It should contain an AB or a BA somewhere. So that is what you can use to do this. So you can even write it in even sigma star AB plus BA sigma star. Okay, fine.
So,
Okay, let's continue. Let me copy this one.
hello, so,
Yes.
so for 2.1, can we write sigma star AB?
No. What about ABB? Yeah.
Sigma star.
You have to write it as sigma star AB sigma star.
Okay, so sir, sigma star here can be A, B, AB, anything like.
Sigma star is essentially A plus B. Sigma stands for A plus B. So sigma is just a notation which can replace A plus B.
Okay. So sigma star AB sigma star is okay, but
Correct. It is correct. Yeah. Okay.
okay, thank you, sir.
Good. Let me just copy this. So we did 2.1, 2.2. Now what about 2.3? So yeah, there are several answers. So I was thinking about writing AA plus AB plus BA plus BB. If it's a finite language, you can just put each of the words together and just put a plus. But this also turns out to be A plus B dot A plus B, as some of you have pointed out. Okay.
Sir, this is also AB square, sigma square.
Yes, correct. Sigma dot sigma. Yeah. Yeah, correct. Okay. Now, see, sigma is just a notation for A plus B. Okay. Yeah. So wait, what is 2.4? Words that contain no A's. That means they have to contain only B's because we are at sigma is equal to A comma B. So this is just B star. Okay. Now what about 2.5? All words ending with an A. So it's A plus B star A. Okay, sigma star A. Let's write it sigma star. Okay, so I guess you get a feeling for writing regular expressions. So let's actually look at formally what are regular expressions. Okay, so we have to do that. Okay. So first, if I have to define formally, I need to tell you the syntax. How do you write regular expressions? So assume that you are given an alphabet sigma. Now, every letter of sigma is a regular expression first. So, for example, if I just say, assume that somewhere, if I just say A, this stands for the singleton A. Okay, so I'll paste this. So every letter is a regular expression. So these two things are some special characters. Epsilon is a regular expression and phi is a regular expression. We will see what they mean. Okay, this we have not seen in our examples. But what we have seen is if R1 is a regular expression and R2 is a regular expression, you can form a bigger regular expression by just putting a plus. Okay, for example, if AB is a regular expression, BA is a regular expression, then you can put a plus or like A plus B star. Okay, this is going to be a regular expression. Another way of getting more complex regular expressions is by doing concatenation. So you R1 dot R2. So typically we do not write the dot. We will just write it as R1, R2. So in particular, A dot B is A. Okay. And finally, how do you get more complex regular expressions? It's by doing the star. Okay. If R is a regular expression, R star is a regular expression. Okay. Now this is how you write the pattern, the expressions. Now you can kind of guess what is the language associated with each expression. So there's a difference. So this is a regular expression. and this is the language associated with that expression. Okay, it will be a set of words. Okay, now this is the regular expression, and the language associated is epsilon, b, bb, and so on. Okay, so now I have given you syntax. I should tell you the semantics of these expressions. That is, what is the language associated with each of them. Okay, now this is again as you would expect. If it's, this is something called as an inductive definition. Okay, so you first define it for the smaller ones and then you define it for the bigger ones. So if my regular expression is of the form just a letter, then the language associated with it is just the singleton set. Okay, so I can also use epsilon in my expressions, in which case L of just epsilon is just the empty string. Okay, now what is phi? It denotes the empty set, which is different from this. So this is a singleton set containing the empty string. See, that's why maybe if you called it the zero string, there will be no confusion. And this one is just the empty set. Okay, and now it's just a technical thing. Okay, don't worry too much. So if I have R1 plus R2, the language associated with this is L of R1 union L of R2. Okay, R1 dot R2, L of R1 dot L of R2, which is what we have seen before. You take one word from R1 and one word from R2 and concatenate. This we have already seen. L of R1 dot L of R2. And this is just L of R1 star. Okay. See, now you kind of, once you see the examples, then this formal thing looks like, why is it done again? Okay. So, but I hope you understand how you associate a meaning to each regular expression, and the meaning is a language. Okay. So I just wanted to explain this thing. So for example, if this is a regular expression, the language associated to this is what? So I take this as my R1, this as my R2, and I look at this thing. So this will be L of R1 union L of R2. Okay. Now if this is my R, this is of the form R1 dot R2, where R1 is A and R2 dot is B. And that is going to be L of R1 dot L of R2, which is L of A dot L of B. Union L of B dot L of A, but L of A is just the singleton A, L of B is the singleton B, and then this is AB, union B. Okay, so just to break it down, right? So, I mean, so L of A star is L of A star, which is just A star. And we have seen this before. If this is a language, we have seen what is a star. It's epsilon, A, and so. Okay, fine. So this finishes the formal definition of what regular expressions are. I'm not going to do this. Instead, let's do some more examples. Okay, so try to write regular expressions for. So what I'll do is I have two, example 3 and example 4. So I'll post both of them together. If someone does one thing before, you can try the next one. Wait a minute. So try these two things out as much as you can. So I'll wait. I'll wait for 5 minutes and I'll give some answers, and the rest I will leave it as an exercise. Okay. So for example, this one I will leave it as an exercise. Ah, no, sorry. This one I will leave it as an exercise. Okay. And let's see if we get to come here. In that case, I will leave example 4 as an exercise. For the moment, try 3.1 and 3.2. I will explain 3.1 and 3.2. And if someone already does it, try the rest. So yeah, so let me just finish 3.1 and 3.2, and then later next class I'll start with the rest. So 3.1, words that do not contain an AB. So if they start with A, they have to just contain A. If they start with B, they have to just contain B. So this makes it A star plus B star. Okay, correct. Words of even length. Okay, this one,
Sir,
yes.
For 3.1, can we not have B A star included in the set?
Sorry, you're right. So if they start with, okay. So if they start with B, they can, yeah, you're right. They can have any number of B's followed by A's. So yeah, so then I don't even need to write this because it's just B star A star. Is this fine? Yeah. Okay. Yeah. Okay. So for the second one, I have A plus B dot A plus B. This is of length 2. Now I need to pump this as many times as I want. So then I have to put a star. Okay. You can also write it as sigma dot sigma star. Okay. Any questions on 3.1 and 3.2? So the rest I will leave it as an exercise. So think about them. Okay. So let
Sir,
me, yes.
can we write 3.2 like A star, AB star, BA star plus BB star in union and
No. Come again. Slowly.
A star plus AB star
No,
plus
it's already wrong. No, A star contains A. It doesn't have equal length, even length. No.
okay.
So what's your expression? A star plus?
AA star. No,
Okay. Sorry.
not A star, sir.
A star.
Plus AB star
Hmm.
plus BA star plus BB star.
And?
And
No, that's what. No, this
sub brackets. A whole star, AB whole star.
Okay. I see what she means. Okay. I see. No. So there is one problem here. A star, there's BB whole star, AB whole star. Yeah, so right. So you see Arpan's answer to this. BB whole star. See, you will only be doing A, and so on. You cannot do AA followed by BB. You see, what you are hinting is AA plus BB plus AB plus BB. So you take all words of unit 2, which is all of this, and then you keep multiplying them. Keep adding, concatenating them. So is this what was the question, and why this is not correct? You understand?
yes, sir. Actually, this star is not like distributed.
No.
That is the thing, no? Okay, that
This
cannot
one
be
is not
distributed.
equal to this.
Okay. Actually, that was my question. Yeah.
Good. Okay. Fine. So I think now it's time to stop. So we have been introduced to what are languages, and we have seen some operations on languages. And then we have introduced this notion of regular expressions, which is a notation for describing languages. So languages as such, they're infinitely many. Infinitely many words. You cannot just enumerate them. Instead, these regular expressions give a succinct way to write languages. So we have seen some syntax, we have seen its semantics, and we have seen some examples. So I hope you get a feel for what regular expressions are. So next class, we will start talking about automata, which will be the basis of algorithms for checking if a string contains a pattern given by a regular expression. Okay, fine. So before I look for other questions, I want to give some good news, which is we need to have quiz 2, which is just logic, the second module. So ideally it will be good to have it early during next week, say Monday or Tuesday. Is Monday a good time? See, Tuesday, it will be like last time, like 3:30 to 6:30, say. But I don't think you will need, so, okay. Monday, is there a possible slot, like in the afternoon?
So Monday is a busy day for us.
Yeah, okay. So then let's keep it on a Tuesday, but then I will need another lecture. Okay, so I will probably ask for a slot either on Wednesday or Thursday next week. Okay, so let's fix next Tuesday, which is what? What is the date? Next Tuesday is 26.
26.
Oh, how does it always have to fall on a holiday? Okay, so guys, I am again sorry because it's a short course, and then if we have 2 holidays already, it will be difficult to find extra slots. So I hope on 26th you are willing to write a quiz. Okay, so
So
it will
take it
just
on
be on.
27th.
Sorry.
So take it on 27th then. 26th you can have the class.
So
If
okay,
you
so you're
want.
willing
Yes,
to have the class
that
on
would be
27th.
better. Wednesday can be the quiz and we can have the.
Sir, actually Wednesday in the second half we don't have anything.
Yeah,
Yeah.
so sir, we can. Last time it was like very late in the evening, so
Okay.
like if everyone in the class is okay, then we can have it like in the early morning sort of time because like everyone is.
Early morning is like, you mean like 10 o'clock?
Yeah. If everyone agrees.
No, actually
Yeah.
Wednesday we have a class. We have a class from 10:30.
No, but I can start it at 2 o'clock or something like that, the quiz.
Yeah.
Say
Yeah.
2 to 5.
That is fine, sir.
That
Yeah.
is okay, sir.
So let's
Yes,
say
sir.
next Wednesday, 27th, 2 to 5.
Uh,
So Wednesday 27th 2 to 5 is the quiz, and we'll have
A
our regular class on
on
26th.
26th. Yeah.
Okay, so that's
Yeah.
fine.
I will just write it here, and I'll also send out a mail for people who are not here. We will have a regular class on 26th Jan, Tuesday. We will have quiz 2 on Wednesday, 27th Jan, between 2 to 5. See, I'm giving 2 to 5 to include the uploading time, because I don't think you will need so much time. See, the quiz will contain some logic puzzles and some inference. You write the sequent, prove the sequent using natural deduction. These kind of questions, okay? And by now, I think most of you are experts in this. So I believe it shouldn't take so much time. But I also understand that you're having a tough time uploading. So I'm counting all of that, and let's say 2 to 5. See, one thing about uploading, use some PDF compress software or just submit it in parts. I think that works. Okay, fine. So then you should try to schedule a tutorial beforehand, like before next Wednesday. Please coordinate with, I'll also tell the TAs to coordinate with you to maybe give some more examples, and then also have a tutorial session. Okay. And I will try to give quiz 1 by that time. Okay. Okay then. So any other questions about regex? Otherwise, the
So,
class is over. Yeah, you can feel free to leave if you want. Yeah.
Sir,
Yes.
sir, in the third part, you're asking words that contain even number of A's, right?
Huh.
So can there be an expression like A B A?
No,
Like
no, wait.
as
So
even number?
Prasun, can we wait for this, because I want others to try it out. So
Uh,
shall I give you an answer to this next class?
Sure. Okay. So that will work.
Yeah.
Sir, could you explain that phi symbol again? Like, what was it?
Phi is just standing for empty set. I mean, it's see, every expression stands for a language. Okay. So
Okay.
phi stands for the language consisting of no words. It's the empty set. See, because when we define a language is a set of words. Then empty set is also a set, right? And this phi denotes that. So I will explain what these things mean. what is this, what is this, and so on.
Okay, got it.
Sir,
Yes.
in Python we have a package called Dari. So can you please give some overview regarding the package? Like these are, I think, similar. I have whatever I
You
have
are putting me in a
seen.
tough position because I know regular expressions, but I do not know Python. So so you should ask Kumar maybe. Who's teaching you Python?
Madhavan sir.
Madhavan is. So great. So you just, ask your question to him. I don't know Python, unfortunately. So what is
Okay, sir.
your question? What do you exactly want to know?
Sir, actually, we were using RE for solving one cryptography assignment and
Okay.
like that stuff. So I found something related to this, but I couldn't understand that package clearly. So that's why I
So
asked
maybe when
you.
you understand regular expressions, then you will be able to understand the package probably by looking at the syntax and your manual.
Yeah, that's also starts with some A and ends with some B, like that only.
Okay, that is
There
the
are some,
standard.
yeah.
Yeah. So I think it's just another. It's just translating this into a Python code. So, or maybe it's directly using. It already has libraries for all these operations. So you can use it for text search or things like this. It's my
Okay,
guess.
sir. Okay, sir. No problem. Thank you.
Sir, how many quizzes will be there before the finals?
So there will be quiz 1, quiz 2, and then a final
Yes.
exam, which contains all of them.
Oh, all three.
Yeah.
Okay, okay. So, and what is the weightage? You must.
So let's try to, I don't know, maybe, see, I want to keep it flexible. For the moment, I kept it as 25, 25, 50, but I am also okay with 30, 30, 40. It depends on the performance.
Okay, sir. Anything works.
Yeah, yeah. There will be significant weightage for both. Yeah.
Okay, sir.
Yeah. Any other questions?
No, sir.
Yeah. Okay then. So then I will probably stop sharing. Yeah. So then I'll see you on Tuesday.
Yes, sir. Thank you, sir.
Yeah.
Thank you, sir. Bye, sir.
Bye.
Okay, thank you, sir.
Thank you.